Welcome back to the spring 2019 semester. Hey guys, this is ACM at UC General Body Meeting number 10, and we'll be discussing serverless computing, one of my favorite topics. And definitely use the attendance link, acm@uc.org/attendance or /c, while I'm going through a few of these update slides. So here's a few resources. We record all of our talks, workshops, etc., and throw them up on our YouTube channel and our archive on GitHub. You can check that out at acm@uc.org/archive, and also our calendar with all of our upcoming events are on acm@uc.org/meetings. And if you check in today's meeting, you'll automatically be added to the listserv, so you'll get notifications about that. And again, be sure to fill out attendance. If you fill out attendance for at least 2 meetings throughout the semester, then you'll be able to vote for officers at the end of the year. So be sure to do that. Upcoming meetings. All meetings are TBD. So we're going to figure that out. But a big question is Wednesdays versus Thursdays. Obviously today's a Thursday. But I wanted to take a quick poll. We're thinking about changing to Wednesdays. Is there anybody here? Raise your hand if Wednesdays at 6 p.m., that's like a no-go, like I have class. Okay, what are your majors? I'm just curious. Computer science. Anybody else? CS, Comp E? Okay, good to know.
Looks like we're screwed either way.
Yeah, either way, we'll figure it out. We'll make the best.
Thursday, 6 a.m.
We'll make the best decision possible to accommodate everyone. So we'll try our best. So what does ACM at UC do? If this is your first meeting, then welcome. We have bi-weekly meetings. You're on one right now. We have tech talks and workshops. We host social events. We host Revolution UC, which is UC's student hackathon. It's over 300 students in size. It's really cool. We have Make UC, which is another hackathon that happened earlier this fall semester. We host ICPC's regional contest, International Collegiate Programming Contest, that happened last semester. We have programming review sessions, often for like C++, Python, your data structures class, stuff like that. And then we have tutoring and office hours. Those times are not correct. We're going to update those for the spring semester. And then we have a couple services, including recorded minutes, our Slack group. So be sure to check those out. Speaking of Slack, Slack is definitely the best way to connect with ACM at UC members. Someone's always on there. Our Slack is over like 300 people strong. It's definitely the best way to connect with people interested in tech at UC, whether you're interested in computer science, Comp E, programming, IT, whatever. There's a lot of channels there to do whatever you want, but just be sure you keep in mind the code of conduct applies on that. So that's ACM Cincy.slack.com. So you can sign up for that. And it's free. Also, Slack updated their logo recently. You noticed. Let's do a poll. How many people like the new? Who has not seen the new Slack logo? Okay. Who likes the new Slack logo? Who does not like the new Slack logo? Okay. I feel like we're kind of split down the middle. Okay. Our code of conduct is at acm@uc.org/conduct if you want to check it out. Basically, we're just dedicated to a harassment-free experience for everyone. This is a big deal. Revolution UC is UC Student Hackathon. It's one of the largest hackathons in Ohio. It's happening this March 2nd and 3rd. At the event, you work on any project you want. It's 24 hours of hacking. You're given resources, free food, mentor support, all that kind of stuff. And it's all about code, community, and self-improvement. So you can learn more at revolutionuc.com, and you can register there too. It's completely free, and it's organized by our student organization, ACM at UC. So be sure to check that out. How many people have registered for the hackathon so far? Okay, so a few hands. I think you should all register for it, especially if you're interested in programming. It's like the top event for programming. We have tons of sponsors from around the area, including GE Aviation, 8451, Kroger Tech, a whole lot more. Just check out the website. Okay, cool. So now we're going to move into the main event, the talk on serverless computing, and I'll be giving this talk. Okay. Get rid of that. If you're interested in following along the slides or any slides, you can go to our archive on GitHub. Here's the name of it. And just scroll down, and the slides are right here. So if you're interested in that, that's where to find it. Okay, let's get into the content. So this talk is called Building Everything on Serverless. Is this clickbait? Maybe. We'll find out. So today's goal really is to tell you all about serverless. Serverless is a form of cloud computing. We'll discuss why it's useful, how does it get started writing apps for it, and why I think it's great for students and college students. So we have a lot to go over. First, we'll talk about cloud apps and hobby projects. We'll go over some motivation for serverless. I can't just sit here and say use this thing because it's cool. We need some motivation for that. We'll look at serverless and serverless compute. We'll look at some examples, bad use cases, good use cases of serverless, look under the hood, and then create some apps with AWS Lambda and serverless framework, and we'll also go over those two. And then that'll be part of the live demo on how to create your first serverless app. So at the end of the talk, you should be fairly confident in serverless terms and even creating your first serverless app. So the first question I have for you is, how do we write and run apps in the cloud? If I'm writing my code locally and I want to put it up somewhere on the internet on a cloud computing platform like AWS or GCP, Google Cloud Platform, what would I do? Or something like Heroku, what would I do? It could be server-side code for a backend, right? For a web app, a mobile app, something else. Could be an API, event-driven. Yeah.
Docker container.
Docker container. Yeah, I agree. So where would you put it? On AWS or something? On EC2? Something like that? Anybody else? Okay. So yeah, you might put your code on a server up in the cloud somewhere, and then have a run command to start your app, right? Or maybe you're using a platform as a service like Heroku, and you just configure a few things and then push to deploy, so your app is live and has an HTTP endpoint. So this is generally a simplified view of the life cycle for your app. So you might have some code, you might be writing your code, testing, and then here's the kicker, you might be provisioning and deploying once you're all done with that. So we write, we test locally, we then decide, hey, we want to put this out on the internet. How do we do that? We have to identify the infrastructure and the deployment strategy. Then we have to provision that infrastructure and deploy. So I think this right here is a burden for developers, this infrastructure, provisioning and deployment, particularly for hobby projects, because really you want to be just concentrating on coding and testing your code. So production, provisioning, and deployment shouldn't really be the first main thing that you're looking at. You should be concentrating on coding and testing. So this is your code, right? You have this awesome app, and you want to get it onto a cloud server somewhere, like a virtual machine. So your code, we'll put it onto a server, and then we'll run it. So anyone in the world, right, can access that API endpoint or whatever. It might have access to a database or data store, logs, cron, HTTPS, and SSH might be the ways to get access to it. So this is a very watered down diagram of what a deployment could be. So our code really needs to go somewhere on a machine, somewhere in the cloud to run. This could be super complicated and time consuming to set up. Also, we want a few things when we are running our code in the cloud. If we're doing this on our laptop, we don't really care about high availability or monitoring, but once we push our app live, we want our app to be highly available and have all the monitoring we need. So in my opinion, there's too much DevOps work in this, right? Too much infrastructure management. So infrastructure management are bad things. So this is the first motivation for serverless. We should be provisioning, deploying, and managing we shouldn't be provisioning, deploying, or managing. It's time-consuming DevOps work. We shouldn't be concentrating on that. We should get rid of it and use cool emojis like this. So if we just got rid of provisioning and deploying, then we could focus on more important things. So really the motivation here is developers, let's abstract away, let's simplify the way we deploy our apps and not worry about servers or infrastructure. Now, this comes at a cost, right? Because we want cloud providers now to decide how to allocate resources to our app. We're no longer making that decision. So things like CPU, memory, storage, scaling, all this stuff are now in the hands of the cloud provider. We've now abstracted ourselves away from that. So this is the whole idea that infrastructure is an implementation detail. I don't care what the infrastructure is like or anything like that. I just care that my code is running on the cloud somewhere. And also the idea that developers should only care about their code. I should be writing apps and not worrying about the infrastructure that it's running on. So the whole thing here is drop the infrastructure. Let's drop the entire provisioning and deployment pieces right here in this life cycle. So let's drop those. So we have a more simplified life cycle now. So this is kind of what serverless is, dropping the whole infrastructure section, the deployment and the provisioning. So this is motivation number one. So we have a second motivation for serverless, which is that idle code that isn't being run, means that you have idle servers, and that's wasted money. So it's waste compute time and, of course, wasted money. What if we could only pay for the time that our code is actually running in the cloud? Well, this is actually cool because serverless will help us do this. Serverless optimizes time idle, so we're not paying for the time that our code is not running. So I just mentioned this thing called serverless. What is that? It's a form of cloud computing, and maybe serverless could help fix these problems. We'll find out in a few minutes. So first I want to set the stage and just show what an example of a serverless app could look like in the cloud. So here's an example. We could have an HTTP API for a web or mobile app. This could be REST, GraphQL, whatever we wanted. And our code is made up of a few pieces. So we have an event that triggers a function where our code lives. And this function can interact with other services, APIs, and monitoring. So our code is designed to do one specific function and do that very well. So this is supposed to be very simplified. And if we have a ton of endpoints in our API, HTTP API for this web or mobile app, then we would try to keep those as isolated as possible. So this, our code is triggered by an HTTPS event, like an HTTP call from a web or mobile app. It may do some logic. It might like update something in a database, retrieve something from a data store. It might contact another API, and of course it'll log to things through monitoring. So this is just an example of what a serverless app could look like. And as an effective serverless, microservices are possible, but we won't talk about that today. Now, this word serverless is a synonym for backend as a service, and it is the ecosystem around serverless computing. So it's the idea that you should be abstracted away from all the services that power your application, letting you just concentrate on your code. So backend as a service includes compute, databases, storage, cache, all that kind of stuff, and it's a basis for serverless computing. So serverless computing refers to function as a service. This is the service that is running your serverless functions in the cloud. This is where your code lives, your very important code that talks to other services and stuff like that. So it is definitely the most important service for serverless apps. It's kind of like a sandbox. It's isolated from everything else unless you tell your code specifically to go out and do something else. Next we have serverless function, which I just mentioned. Serverless functions are the smallest unit of serverless. They are small, lightweight pieces of code that you write to accomplish a very specific goal. And functions can be triggered by any event in that diagram that we just saw. It can be triggered by an HTTPS event. It could be triggered from a message from another service, a cron job, something's updated in a database, something's added to a queue, literally anything our functions can be triggered by. And our functions, our code runs in very short-lived stateless containers that are triggered by events. And we'll talk more about these containers a little bit later. So now we've defined 3 terms, that really key terms for serverless. We have serverless backend as a service, we have serverless compute, and we have serverless functions. Note that serverless and serverless compute are 2 separate ideas, but a lot of times online in forums, or if you're talking to someone, sometimes they'll say serverless when they meant serverless compute. Sometimes people just shorten it. It can be kind of annoying, but some people do it. So serverless is really just another abstraction on top of other abstractions in the cloud that we already have. It's all about just writing functions and letting the cloud handle everything else. So we just set requirements and we deploy and let our cloud provider handle the provisioning and deployment I talked about earlier, the scaling, availability, the monitoring, all that kind of stuff. So this is kind of the level of abstraction that we've gotten to. So first we had infrastructure as a service. What is infrastructure as a service? Can someone say? Infrastructure as a service? Yeah.
They'll just provide some hardware specs that we have to manage software and operating system on our own.
Yeah, that's very good. So it's like we have bare metal, and then on top of that we have like the bare minimum of software on top of that, where like we have servers, virtual machines, all this kind of stuff that a cloud provider offers. An example of an infrastructure as a service is AWS, Google Cloud Platform, stuff like that. So they're really offering like pure servers, pure databases, stuff like that to help you build your apps. And this requires a ton of management and provisioning, security, that kind of stuff. Then we have platform as a service, which is definitely an abstraction on top of infrastructure as a service. Does anybody know an example of a platform as a service out there? Yes, Nick.
Pretty much everything in Google Cloud.
Yes. Also Heroku, right? Heroku is a platform as a service. So on platform as a service, so I just said we're abstracted from infrastructure as a service. So that's the idea that I deploy somewhere, and I don't really care how or where my code is run. I just care that it is running somewhere in the cloud and that things are being provisioned. Then function as a service takes this a step further and doesn't really care at all how my code is running or where it's running. I just care that it is running somewhere. So it's another leap in abstraction. So we have function as a service, platform as a service, and infrastructure as a service. But we're really just talking about function as a service today. So you might be saying, there are servers. This is a lie. It's not serverless, right? So serverless is definitely misleading. It's not even slightly misleading. It is definitely misleading. There are servers that are powering our apps in serverless computing, but we're just abstracted from them. We're simplified. And the big kicker here in serverless is that we pay only for the time that our code is running in the cloud. If our code is sitting there idle without any requests coming through, we don't pay anything. So some good use cases of serverless. I have 3 of them. There are a lot more, but here's 3. An HTTP API, just like I mentioned earlier. For a web or mobile app, we have an HTTPS call that comes through. Then we have a function that has our code in it. So this could be like REST, GraphQL, whatever. And it talks to a database or a data store, some kind of service, and then responds back to the client that made that request to the event. So this is use case number 1. An example of this use case is actually on the ACM website. We have a little Slack badge there. And this Slack badge is powered by serverless. So whenever a request comes in for a web page render, we make a request to serverless on AWS Lambda, which we'll talk about later. This fetches, our function is activated. It fetches the latest number of people active in Slack and returns that as an SVG image, which just goes into our web page. So it's a very simple example of a serverless app. Next are automated tasks. This is also a really good use case of serverless. Say we have a scheduled event, like we want to run something every day or every hour, something like that. This is totally a good use case for serverless. Cron jobs, backups, emails, that kind of stuff. So we can have a scheduled event which kicks off our serverless function, and we maybe get some data, pull some data, edit some data, and then we could like report on something, message someone, do something like that. So automated tasks are another example of serverless. Finally, here's another awesome example, image and video resizing. You'll see this example a lot online. Say we have an event where we watch a bucket on AWS S3. So whenever a new image or video is uploaded to S3, we act upon that. We grab that image and then we resize it and throw it somewhere else on an S3 bucket. So this would be cool for image or video resizing. And this is just an example of data processing. Data processing is also a good use case of serverless. We can manipulate data, pull the data, put it into a different database, combine data, whatever we wanted to do. So those are 3 use cases of serverless. Now, bad use cases. Anything that requires persistent connections or state sharing, or state in general, are bad use cases for serverless. For example, WebSockets are a bad use case for serverless. We'll talk more about this when we get to containers, but really anything with state sharing are bad use cases. You might be saying, well, how do I write apps with state in serverless? The answer is that your functions should not contain any state, but the services that your serverless function is contacting, like databases, other APIs, can be stateful. So we can still write stateful apps with our stateless function. So you might be asking, this talk was called Building Everything on Serverless. It's a lie, right? We can't build everything on serverless. We can build some things on serverless. So that should be the real title of the talk, should be Building Some Things on Serverless. So again, anything that requires state persistent connections are just a bad use case. So next up, we're going to switch over to an idea of containers. We'll gloss over this really quickly, but containers are the thing that power serverless. If you are interested in anything related to cloud computing, I strongly recommend you check out containers. Literally just Google containers or Docker online, and you'll get a ton of resources. The magic of serverless does require containers. Containers run our functions and are completely independent from one another. When an event comes in, a request can be handled by a pre-existing container, but in other situations it could be handled by a new container. It just depends on the demand. So the container that we're using in serverless is never guaranteed. This is how we get that high availability that we want. So theoretically, if we had infinite requests and infinite compute power, it wouldn't matter. We would scale on demand. And as a result of these containers, all of our code is written to be stateless. So here's an example of this high availability. A very simple HTTP endpoint. So how does this work? So we have an event that comes through, someone requests an HTTPS endpoint, that kicks off our function. Say we request this function 4 times at the same time. Then this means 4 containers are simultaneously run independently to complete all 4 requests. Therefore, we don't really have a limit on the number of simultaneous requests to a function on serverless. In practice, this is actually not true. For example, on AWS, they restrict you to 1,000 simultaneous requests. At the same time, you can get this increased to whatever you want. It's just for safety, so if you do recursion, you don't keep on recursing through and like racking up a huge bill, because that would be annoying. So theoretically, again, if we had unlimited resources, we could send an infinite number of requests to a function and never have to worry about our system being bogged down. So that's pretty cool. Again, each of these instances is a new container if all the requests were to come in simultaneously.
So 1,000 per user or 1,000?
1,000 per user. Yeah, I think it's per user. Yeah, I don't think it's per function. Yeah, it is low on purpose so that you have to ask them to change it when you want to do something with super high availability, like in enterprise. So what are containers? I never really said that. Again, you should look into this more if you're interested. But containers package code into an image that can be run almost anywhere. So things like Docker are container virtualization runtimes. So anywhere that you have Docker installed, you can run a Docker container. These containers are super lightweight and simple. They all each have their like own OS on them, and then you package your code into that container. That's at like a very high level. You should definitely read more up on containers if you're interested in that. Just give it a Google. I'm sure you'll get a ton of hits. And also container reuse is interesting. If you're interested in that, I have a link to an article on Amazon's website in the slides. There's a lot of cool stuff into how AWS specifically orchestrates their containers to be reusable and scalable on serverless. So read that if you're interested. So we're going to switch gears right now into AWS Lambda. There are many ways to run your serverless code in the cloud. There's AWS Lambda from Amazon, Azure Functions from Microsoft, Google Cloud Functions from Google, and a whole lot more. But today we'll be focusing on AWS Lambda, not only because it was the first serverless compute platform to ever come out in 2014, but also because it's the most popular. So AWS Lambda is a function as a service. And you can read their mission statement here: run code without thinking about servers, pay only for the compute time you consume. So this is, again, really a goal of serverless. So AWS Lambda supports many different programming languages to write your serverless code. Node.js, Java, C#, Python, and Go are all supported. Also, you can run any binary you want on AWS Lambda. It just has to be, the binary has to be compiled on an Amazon Linux machine, and then it'll work. So that's pretty cool. Also on AWS Lambda and many other serverless compute services on other providers, we're restricted to one virtual core. So we can choose how much memory we give to each function. Now you might be saying, one virtual core, that's not a lot. Yeah, it's kind of like by design that way. So when we're architecting serverless apps, we try to avoid situations where there's multi-threading and try to design our apps that way. So here's some events that AWS Lambda supports. The list really goes on, from simple things like an HTTPS call, an event stream, something's uploaded to an S3 bucket or deleted from an S3 bucket, something's updated or removed in a database, a new item is added to a queue on AWS Simple Queue service, something happens in a log we're watching, and a whole lot more. So these are all ways that you can trigger functions. In today's demo, we'll pretty much only be looking at HTTP calls and one other event source, but there's a ton of different ways to trigger your functions. What about the cost? Serverless computing for college students? Well, I said this in the beginning. I think serverless computing is great for college students because it's really, really cheap. So how do we compute how much money we're actually using on our serverless functions? Well, it's the number of requests that are coming through, plus the compute time in gigabyte seconds. So the number of requests are literally the number of requests on your functions, and compute time in gigabyte seconds is calculated by taking the total time that your functions ran that month times the fixed amount of memory allocated to those functions, and that is how we get gigabyte seconds. So specifically on AWS Lambda, it's pretty cheap. So per 1 million requests, it's 2 cents. Per gigabyte second, it's $0.0001667. So this is pretty cheap. So let's look at an example. So say you have a sample function and it runs 1 million times in a month, and it takes about 800 milliseconds per request. And for this function, we only need 256 megabytes of RAM. That's 0.25 gigs of memory. So for the 1 million requests, that would only be 2 cents. So not a lot there.
That's 20 cents.
Oh, shoot. That should be 2. Let's edit it right now. 2 cents. Oh, did I say 2 cents or 20 cents?
You said 2 cents.
Okay, I meant 20 cents. Okay, my bad on that one. Yeah, so per 1 million requests on AWS, it's 20 cents, not 2 cents. So in this example, the 1 million requests cost 20 cents. Then we have to figure out our compute time. So this is our 1 million requests multiplied by how many seconds it took for each function. So we do 1 million multiplied by 0.8 seconds, and we get 800,000 seconds. Now we take this 800,000 and we multiply that by how much memory we used. 0.25 gigs is how much we used. So that comes out to 200,000 gigabyte seconds. Multiply that number by the rate for gigabyte seconds, and we get $3.34. Now we just have to add them up together, and that's how much we're paying per month for 1 million requests on AWS Lambda. So you can see this is really, really cheap. And I think it's great for college students for this exact reason. So say if you scale this up or down the number of requests or the milliseconds per request, say you had like 1,000 requests per month and everything else stayed the same, you would be paying pennies each month. And that's what I do. So I highly recommend you try it out for that reason. Now AWS offers a free tier that lasts 1 year. Many of you probably have tried this before, but if you haven't, you can check it out on their website. You get your first 1 million Lambda requests, AWS Lambda requests, free every month. And you also get your first 400,000 gigabyte seconds of compute time free every month. So basically you're paying nothing just for trying out AWS Lambda for your first year. Also, Google Cloud Platform offers a very similar deal. So do some other cloud providers. Also, the free tier comes with a lot of other services other than AWS Lambda. So that is AWS Lambda, and we're going to use this in the demo. But first, we need a tool to help us get our code live in the cloud, get our serverless app live in the cloud. So how do we do that? Well, we need some kind of tool to get our code locally on our machine up on AWS Lambda. So one tool that does this is Serverless Framework. You can read about it at serverless.com. Serverless Framework is a very popular open source toolkit for writing and deploying serverless computing applications. It's definitely one of the best frameworks out there. Now, be sure to note that Serverless and Serverless Framework are not the same things at all. Serverless is the open source framework and toolkit that helps with function deployment and development. Serverless is just the idea that we should be abstracted away from our servers or any infrastructure. So here's the Serverless homepage. They claim to be the most widely adopted toolkit for serverless apps. This is most likely true. Again, it is a very giant toolbox. You could argue that it's kind of like bloated. You might be right. It offers a very simple command line interface for writing and deploying your apps, which we'll see in the demo. It's easy as writing your code in a file, supplying a YAML file with your configuration, and with Serverless Framework and Serverless, it takes care of the rest. Now, a cool thing here is Serverless Framework is cloud agnostic. It has a very large active community because it is an open source project. It supports all of these: Lambda, Azure Functions, GCP Functions, Kubeless, which is serverless on Kubernetes, if you're interested in that, IBM OpenWhisk, and even Cloudflare and Twilio, which are really awesome. You can write serverless on Cloudflare. So Serverless Framework is cloud agnostic. So really, why use a framework here? Why do we need a framework? We don't need it. We can get away without it. There are other smaller toolkits that different cloud providers offer, but Serverless Framework is really just a comprehensive toolkit. It offers simple environments for developing your serverless apps. You have portability between cloud providers, so really you don't have vendor lock-in. There's a simple command line interface to configure, test, and deploy. And of course, by the serverless goal, it abstracts you from unnecessary DevOps work, so you can just focus on your code. Also, you can throw this into a CI/CD environment and just have your functions deploy straight from Serverless Framework. So again, you can read more about serverless framework at serverless.com. But for now, we're just going to head into the live demo and try to write our first serverless app. And I hope you all see that it is really easy to get started. So this first example is a simple HTTP endpoint, kind of like the hello world of serverless. We're going to have an event, an HTTPS event. Whenever it's triggered, it's going to activate our function. Our function is just going to respond with status code 200 and write back some JSON that, hey, I'm alive and I'm working. So this is kind of like the simplest possible serverless app. We're going to head into it now. So up here on the left, I have the AWS Lambda console. On the right, I have my terminal. AWS Lambda console, as you can see, I don't have any functions in this list so far, but we're just going to go ahead and deploy one. But first, we need to write one. So I'm going to make a directory called simple HTTP. Go into that. And first, there's nothing in here. We need some code for our serverless function. So I'm going to be writing this in Node.js. So let's open this up. Cool. So we have our index.js. So in serverless, you need an event hook. An event hook is provided to you to start your serverless code. So it's kind of like an entry point for your serverless app. So here, module.exports .handler will be our entry point into the serverless app. And this is where our function is located. So our handler on serverless requires three things: the event, the context, and the callback. So the event has all of the, so if this is an HTTP event, the event would have like also HTTP data like headers, any payloads that are coming through, or if we're taking a job off a queue, it would just have the job in the event. Whatever the data is that's triggering our function, that's going to be an event. Now context, it's not widely used, but it is there just in case you want to check out like the context of this function, what its name is, how it was triggered, that kind of stuff, kind of like metadata. And then our callback is how we're going to exit this serverless function when we're done with our work. If you're familiar with callbacks in other languages, this is literally the same idea. So to end our serverless function, we would call the callback with our error, which hopefully would be nothing, null, and our data. So this is the simplest possible serverless function. However, obviously this won't work because what is data? This would not work. So what I'm going to do is, since we're returning, yeah, Zach.
Is the callback run on like the same like serverless instance, or is it run like it's sent over some network somewhere? Does that make sense?
You're saying this callback?
Yeah. Like where's that run in the end? Is it the same program?
So the callback is called inside our container, and that sends a message to like AWS Lambda or GCP or whatever saying, hey, I finished.
Okay.
You do the next step, which is hopefully to respond or take that data, do whatever, and then shut down the container if necessary, if the container won't be reused. Yeah. So we're abstracted away. So we don't know exactly what's going to happen to this container after we're done with it. Cool. So we need, since we're responding to an HTTP event, we need to respond with some HTTP data. So I'm going to create a response object, give it a status code of 200. So we made it successfully. Whoops. Const response. Cool. And then I'm also going to add some a body to it. I'm just going to say my data, my body is right here. And then I'm going to respond with some JSON data. So const body is just a message saying it's working. And of course, we want to respond with JSON, but if we're doing that over HTTP, we need to stringify it. So I'm going to do JSON.stringify. This is very easy in Node.js. Next, I'm going to replace this data with the response object. So now we are going to respond to this event in our serverless function, get a body with a message just saying it's working. We're going to put that into a response object with status code 200, telling the client that, yeah, we made it. We are responding OK. Then we're going to stringify our body and just return that in the response object. Finally, we need to tell serverless that we're done running this function. So we're going to use the callback with no error and with our response object as the data. So this is cool. So we have our serverless function. And now we can test and deploy it. But before we can do that, we need some kind of configuration to tell serverless where our code is, where our function is, and what events we want to react to. So all I need to do is create a serverless.yaml file. So this serverless.yaml file is the bare bones for configuration. So this serverless.yaml is the only configuration you'll ever have to do. So in this, I need a service name. I'm going to call this serverless, simple HTTP. Next, I need to list out my functions. So I have some functions here. The first one, I'm just going to call this hello, as in hello world. The handler, well, let's check this out. So our Node.js file is called index.js, and our function is called handler, our handler function. So our handler is going to be index.handler. So this is really all we need, but we need to react to events too. So specifically, I want to react to an HTTP event. And the method for that event, I want it to be a GET request. So I can just hit it in my browser. And then the path for that is, by default, it is root. So I'll just say that in my configuration anyway. So awesome. We're pretty much there. So now we can run serverless, invoke, local, with the name of our function, which is hello. So this, we're now using the serverless command line interface to invoke our function locally. If I just removed the local right here, then it would try to invoke our function on like a cloud provider, like AWS Lambda, if it were online. So let's try to run this. Oh no, there's an error. Provider property is missing from the serverless.yaml. So we need some extra things right here. We need to specify a provider. Where are we going to run this code in the cloud? Well, I want to run it on AWS. And the runtime for it is Node.js. Specifically, Node.js 8.10 is my version. Next, I'm going to set the memory size. You don't have to do this, but I'm going to do it. I'm going to set it to the lowest memory size possible, 128 megabytes. And the region that I want to be in, I don't have to set this either, but I want to set it to North Virginia, which is US East 1 in the Amazon cloud. So now if we run the same command, we can test our function locally, and we should get back, hey, there's our response that we were expecting. Just disregard that. I hooked that in earlier for fun. So we got our status code, we got our body with our stringified JSON. Notice it's not real JSON, it's stringified. So really, we're ready to deploy. So to do that, all I have to do is serverless deploy, and it'll deploy to AWS. So let's do it. Now the first deploy takes a little time. So does anybody have any questions? Yeah.
Can you make an endpoint on your local system that runs through localhost, so you can test like other?
So like connect services together or something like that. Yeah, you totally could. Yeah.
With the serverless.
Yeah.
framework?
Yeah, there are some serverless framework. Of course, has a large community, like I said, and there's a lot of plugins that help you with offline development, like where your database is running locally on your machine, and your function is also running locally on your machine, so you can test them that way before you deploy. Yeah. So if you're on AWS and you had like a DynamoDB instance, that you wanted to hit in your serverless function, you could replicate that functionality locally on your machine without contacting AWS. So that's possible, yeah. All right, we're nearing completion here. Yeah.
When you run serverless deploy, it automatically deploys it to your account, right?
Yeah.
So you have to give it some sort of API keys or something.
Yeah. So specifically, I'll show the link to the serverless start guide. Oh, it just finished. I'll show the link to the serverless start guide at the end. But it requires you, like if you're an AWS user, you would take your API keys and then put that in your home/.aws directory. And that's the AWS standard for that kind of stuff. So when I did serverless deploy, it looked at my API keys for AWS. It got those and deployed to my account. So it's not deploying to some random account. Okay, so our function deployed, and we're given right away an endpoint to hit it at. But let's see if it is in our list. It is. So I'm on the Lambda dashboard. I can see my function. Here it is. Here's another visual of what's happening. I have an event, HTTP event that's coming in, hitting my function, and anything that we log out to the console will be saved here in CloudWatch logs. And here's that function code that we just had. Cool. So let's try to hit it. Cool. It's working. So that took all of like 5 minutes to get up and running on serverless. Now say there's a bug in the program. There's a grammar error right here, right? This is no good. We want to fix that. It working? No. It's working. Okay, does anybody know if this is actually like the correct grammar for is this correct? Okay, cool. So now I corrected it. I want to test locally. Of course, you all should test locally, right? Everyone tests locally. So there it is. Okay, we just tested it. It's working. So now I'm just going to do a serverless deploy again. And this will take a shorter amount of time because we're just updating an existing function. Any other questions about serverless in general? Anything like that? Okay. Cool. It deployed. That was very quick. Awesome. And if we refresh, we should see it's working. So our function has been updated and redeployed just like that. Pretty easy. So you can see how easy it is to get your stuff up on serverless and deploy it. So that was demo number 1. So demo number 2 is something a little bit more complicated, but not too much more complicated. So I want to get the latest weather every day on my phone, right? So I want to schedule an event that goes every morning, so every 24 hours. It activates my code, which gets the weather data from darksky.net's API, and then sends that as an email through Amazon Simple Email Service. Of course, we could use any email service we wanted, but I'm on AWS, so I think I'll use Amazon Simple Email Service. So we can do this. The scheduled event is kind of like a cron job, if you've ever set up a cron job on a server before. And this will get the latest weather in Cincinnati and send it to my email address. And this will demonstrate kind of how that we can very easily write serverless apps that interact with other APIs like darksky.net and SES. So this will be really cool. So let's get into it. So I actually already have most of this code written, pretty much all of it written. Scheduled weather. Okay, cool. So this is the code for my function. So this is a fairly larger function, right? The other one that we wrote was only a few lines. This one still has an index.js with a handler. With a handler with the same event, context, and callback. So we are hooking into the same exact thing. However, this one, we're getting the forecast data, then we're sending an email with that data to an email address. And then finally, we're calling that callback down here with no error and just a status message saying that, hey, it worked. So in our logs, we can see that it worked. If there were ever an error here, we're catching the error, and we'll call back with the error and with no data message because there was an error. And we're logging that out. So in the logs that come for free in serverless, we can check that very, very easily. So again, we're pretty much like abstracted from all these things, right? We're abstracted from the API that we're getting our weather data from. We're abstracted from the email service that we're sending our emails through. And our logs work for free, basically. We don't have to set up logging. So the forecast is not very interesting. We're just hitting Dark Skies API. If you ever need a weather API, Dark Sky is really cool. These are the coordinates for the University of Cincinnati. We're getting that, and then we're just kind of getting a summary, a daily summary, and the current temperature, and resolving that back to the main function. Then we take that data, the weather data, we go over and we send an email with that data over SES. So we send it to a specific email address with the email data, and then we kick off that message to SES. And then when it's done, we'll call it back to this main function to let it know that it's finished. Finally, this main callback will run so that we're totally finished with the function. So let's actually try this out. I'm just going to deploy it straight to AWS. And in my configuration file here, for the sake of demo, I scheduled the rate to be 1 minute. So every 1 minute, I'll get an email address to my Gmail account. And that's going to be really fun. And you can see I have an API key for Dark Sky, and I put in my email address as an environment variable as well. I have pretty much the same provider set up here. You'll notice I have a role statement up here for security purposes. So I'm telling AWS, hey, this function can access simple email service, and it has rights to send email. And I just threw in a star here, which is very bad practice. But I'm saying you can send to any resource in SES that you want. So let's go ahead and deploy this so I'll get an email every minute. So deploy. Cool, so this could take some time. And you'll notice in the last function, the total size of the function was like 300 bytes. But for this one, it's going to be in like the 8 or 9 megabyte range. And that's because there's some dependencies that are packaged up along with this. See, it's 8.91 megabytes. So on serverless, whenever you deploy your serverless code, it literally packages up every single dependency, what language you're using. No matter what language you're using, it's going to package up every single dependency in a single zip, and then upload that to your cloud platform provider of choice. So when your serverless function runs, it has all the dependencies it needs right there. So it's isolated from everything else. There's no dependency sharing or state sharing between serverless functions. Looks like we're still going. Yes?
How does it bundle the dependencies? Does it mean Webpack or anything else?
Webpack?
Yeah, how does it bundle the dependencies?
Oh, how does it? It doesn't use anything fancy like Webpack or anything like that. It literally just copies. For example, if you're using Node.js, it'll literally just copy the Node modules folder in with your code, zip that all up, and throw it up to AWS. So there's no like tool like Webpack being used.
So if I have a little large app that can like benefit from something like tree shaking.
Yeah.
So that's all. I have to do it myself then. You like Webpack.
So there is a limit to like the package size that you can upload to AWS Lambda. I'm not sure what exactly it is. It's definitely in the megabytes. I think it's like 200, 250 megabytes, something like that. I'm not exactly sure, but there is a limit to your package size. So that really makes you like write very simple apps with like a few amount of dependencies. Yeah, so if you went over that limit, which I have before, I have written a Java application that went on AWS Lambda, and AWS wouldn't accept it because the size of the package was too large, so we had to break it up. And that is why you should never use Java. But that's a whole nother talk. Okay, other questions? Yeah.
So what device is actually doing the counting, like every minute it does the thing? Is that like the server or your computer?
Yeah. So it's definitely in the cloud, this thing that's counting and doing my function every minute. It's in the cloud. It's not on my laptop. So if I were...
Are you getting charged like for the like indefinite?
Good question.
Counting?
Yeah, so if we had like a traditional server, say you went to like DigitalOcean or AWS EC2 and you just spun up a virtual machine, you put your code on there and then you set up a cron job to run like every minute, you would be paying for all of that uptime, even between the time that your code is not running. However, on Lambda, no, you do not pay for the time in between those job runs. So I schedule it for 1 minute, I'll only pay for that time at 1 minute. The time in between my code stops running, and the next time it starts running, which should be about a minute, I won't be paying for anything. Yeah, so there is a scheduler. Of course, we don't care how it works. We just care that it does work. And we hope that AWS Lambda never goes down. Yeah. Okay, so we should be good. We should be receiving some emails now, hopefully. Oh, Zach, didn't you have a question?
Oh, yeah, I was just gonna say, like, so if you want to, so like, it looks like it's uploading something to S3 there,
Yeah.
and so like, if you want to like get rid of this Lambda, like, does it kind of take everything down with it, or, like, does that make sense? Like, what's the cleanup?
The cleanup, yeah. Yeah, I'll do the cleanup in a minute
Sure.
for a demo. So you run, whenever you're done, you run serverless remove in your command line, or you could run it from anywhere really, as long as you have access to those API keys. And serverless framework will find all of the things that it uploaded to AWS, including everything to S3, CloudFormation, all these different services, in addition to AWS Lambda, and it'll delete all of them, so there's no trace of what happened, and won't be billed anymore.
Is that, that's a feature of serverless for, like, of Lambda?
It's definitely a feature of serverless framework. Yeah, you could do the same thing just by manually going into AWS and clicking delete on a bunch of things, but I don't want to do that. So yeah, Nick.
Do you have to pay for the time it takes to spin up and spin down your virtual, like to launch and close your virtual code?
Like launching and closing your container that the code is running in?
Yeah.
Good question.
And also, every time you start a code, it has to like load that into memory and reserve anything it needs.
It does, yeah. You should read that article that I put in the container reuse slide on Amazon's website. That's a really good point. So serverless containers have a few different states. They actually only have 2 states, warm and cold. So I think that your second question was, if I have a request that comes through, right, and I finish the request, what happens to the container? Was that your second question?
No, are you paying for the time it takes
Oh.
to spin up the container? Are you paying for the time it takes to load in and reserve resources for your program?
Okay, so no, you're not paying for the time it takes to spin up your container. Really, so for example, really you should always have at least one container running ready to accept requests all the time. If the design on AWS's behalf is correct. So there should always be a container running there and warmed up. So immediately when a request comes in, it should be activated and your code should start running. However, if we're in a scaling situation and a lot of requests are coming through and we have to spin up a new container, then it does take a few milliseconds for that container, just a few milliseconds, right, for your container to get spun up and run. So in that case, yes, you are paying a little bit of time for that container to get started, and that request that comes through will take a little bit longer to be fulfilled.
Okay.
Yeah. Good?
Yeah.
Okay, cool. So as we've been talking, I've been getting several emails. Oh boy. So here's one. So it says unsafe because I'm sending email through AmazonSES.com and I'm pretending to be my email address, bastardno@gmail.com. So it's kind of saying like, hey, this might be unsafe, but it's cool. So there's my content right there. It's foggy and 38.05 degrees Fahrenheit. I'm not sure if that's correct. It's kind of dark outside, so I don't know if it's foggy. But it is working, and we're getting a ton of emails coming through. So that's cool. So if I want to stop receiving these emails, which I do, all I have to do, let's see what it is in this list. It is in this list. So there's our scheduled weather app. So I have an event that's coming through. That's that cron job that runs every 1 minute. And the things that it contacts are SES to send the email and logs. Also, it's contacting that API, but Amazon doesn't care about that API because it's not one of their services. And, that's my API key. Okay, I'm going to delete that API key after this presentation is over. Okay, so all I have to do to take down this function is run serverless remove. This is actually pretty quick. So it's going to remove everything from S3. It's going to remove my CloudFormation files that it took to get my function up and running. We should be good. So let's check it out. Our function's still there. Okay, any other questions while we wait for this?
Can you manage multiple functions or multiple lambda functions under the same YAML?
Yes. Yeah, so that YAML file, I could add, so I had weather, I could add like function 2 right here and just type in another handler. If I had another function in here, like handler 2. So I can have as many functions as I want in one YAML. Yeah. Also, I can have as many events as I want in one Lambda. So I could have this triggered by both a schedule event and an HTTP event. That would work.
Do you have to set up that scheduler separately in AWS?
Mm-mm. I just
So that's
specify.
part of Lambda.
Yeah.
Okay.
It is part of Lambda. That's correct. Okay, it looks like it finished. So my serverless code for that is totally off of AWS. Let's check that it is. It's gone. So I shouldn't be receiving emails anymore. Cool. So that is the final demo. So really, I want to conclude by just saying that serverless really offers an awesome way to get started with cloud computing, or just use cloud computing reliably for a very low cost. It's really easy to get started. You saw there my first serverless function took about 5 minutes, and that included deployment. And it is really great for college students because of the low cost. So I think you all should use serverless. Here are some resources. These slides again are on the ACM archive, so you can get at all of these resources. Specifically, the second bullet point has the best quick start guide to AWS Lambda and serverless framework that you can get, including setting up your API keys on AWS, installing serverless, getting started with your first function. So that's a really cool resource. So that is all I have. Thanks for coming to my talk about serverless computing. So if you want to grab pizza, go ahead, grab some pizza. If you have any questions, you can just ask me. I'm happy to answer them. Otherwise, look out for an email on the next meeting. That date is TBD. But thank you all for coming tonight.